Hi everyone, welcome back to my number sense series. This is the start of our number theory series, and today we are going to be talking about prime numbers. Now, some of you may already know the definition of prime numbers, but you may not know how important prime numbers are. Prime numbers are like the building block of math, and we'll learn about that when we get to prime factorization. But prime numbers are so important in pretty much every area of math, especially number theory. Number theory is a very big field, but in number sense, they like to test you on very specific parts of it, and that's what we're going to focus on. But it has to start with prime numbers. Now, a prime number is a number that is not divisible by any number except for itself and 1. For example, 9 wouldn't be prime because it's divisible by 3. You can see on here maybe 45 isn't prime because it's divisible by 5. And in fact, you can notice every single prime number does not end with a 2 or a 5 except for 2 and 5. And that's because if it ends with a 2, you know it's even. And if it ends with a 5, you know it's divisible by 5. Similarly, it can't end with any other even digits, and it also can't end with 0. So another interesting thing to notice here that will be relevant is that 2 is the only even prime number, because every other prime number, if it's even, well, it's obviously divisible by 2, so it wouldn't be prime. But 2 is itself, so being divisible by 2 doesn't stop it from being prime. Also, another thing, mathematicians are a little bit iffy on if 1 is prime or not, but the general consensus is that 1 is its own thing. We can't call it composite, which is not prime, but we can't call it prime either, so 1 is doing its own thing. So when we list prime numbers, we don't count 1. Now, this is every single prime number from 1 to 100, and notice that there are 25 of them. This is an important number to know. It shows up sometimes in math contests even. There are 25 prime numbers from 1 to 100, and here they are. The biggest one is 97, and a number that people often think is prime but isn't is 91. Notice how 91 isn't here. It's 7 times 13, and that trips up a lot of people when they're doing this stuff for the first time. Not 91, but 97. Okay, so number sense isn't going to do too much with explicitly only prime numbers, and really there are two kinds of problems. The first problem is where they ask you, how many prime numbers are there? So this is basically like asking, did you memorize your primes? If not, good. If so, good. If not, you're going to spend a little bit of time thinking about it. Second kind of problem is very special, and I'll tell you about this one when we get there. But this first kind of problem, it's really just saying, okay, do you have your primes memorized? Because the only way to do this problem is actually just think about what primes are there from 30 to 50. There's no trick, sadly. You just have to have your primes memorized. So this is why I memorize every single prime from 1 to 100. I don't have any primes memorized beyond 100 because I've never ever needed it. But knowing every prime from 1 to 100, there's only 25 of them, is going to be very helpful. And also, it'll help you to prime factorize because you can look at a number and then know if it's prime or not. And that can save you a lot of time when you're trying to prime factorize, which is something that we'll talk about in a future video. But yeah, for this problem, what I would do, my thought process in reading this is just, okay, I'm going to go through all the primes. So I'd say, there's 31, there's 37, there's 41, there's 43, and there's 47, and that makes 5, so I'd write down 5. Not very exciting, but necessary to know. But the second kind of problem is very interesting. Ask, if the sum of two prime numbers is 85, what is their product? Number sense is going to use this problem with a lot of different numbers. You might see 69 here. You might see 15 here. You could see 99 here. But they all have one thing in common. And it's that they're always going to make this an odd number. Here's why. Every prime is odd, except for 2. So if we add 2 odd numbers, what do we get? Get an even number. But 85 is odd, so we know it can't be adding 2 odd numbers. Well, that means one of the primes has to be even, but there's only one even prime, and it's 2. So really, this is saying 2 plus a prime equals 85. So obviously, the other prime is 83. And so this literally just automatically tells us what the 2 primes are, because we are looking at something called parity, if it's odd or even, and that tells us that one of the primes must be 2. Now, number sense is going to repeat this problem with a lot of different numbers, but it's always going to be that one of the numbers is 2. You can tell that one of the numbers is 2 because it's odd. So, to finish off the problem, their product is just 2 times 83, which is 166. So short video today, but this is just an introduction to prime numbers because we're going to be needing to think about prime numbers for a lot of the other number theory videos, especially prime factorization, which is a big idea, not only in number sense, but also just math generally. You have to know how to prime factorize numbers. And we'll also be thinking about prime factorization a little bit when we think about divisibility rules, which are a really, really cool thing that we also learn for number sense, but is also super helpful beyond. As in my experience, I use this in every math class I've ever been. So that's it for today. The only real takeaway from here is this archetype of problem. Remember that 2 is the only even prime, and memorize your primes, and that is going to set you up very well for the rest of number theory. So that's going to be it for today. I hope it was helpful. Thank you guys so much for watching, and I'll see you next time.